Hello students. As you know, due to outbreak of COVID-19 virus, the nation is under lockdown. Schools and tuition classes are closed. Under these circumstances, to help you all, from now I will take virtual classes on physics and chemistry of class 9. I am requesting you to follow the classes and to do your homework on time. So today's class is on matter in our surroundings, and today's lesson is matter and its structure. Students, all objects, in fact everything in this universe, is made up of materials which scientists have named matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, everything is matter. Matter can be seen, tasted, smelled, or felt. Okay, so all objects, in fact, everything in this universe is made up of matter. Now we can identify matter that anything that has mass and volume is called matter. That is, matter must have at least some mass and it must occupy some volume. Okay, now we see the physical nature of matter. Matter is made up of particles. All matter is made up of small units which is called particles. For example, if we take a matter and we break down it into smaller pieces, now this small piece, once again we can break into smaller pieces. In this way, if we continue to break the pieces, ultimately we find one uh, last part which cannot be divided further, that is indivisible. This part is called particles. That is, particle is the building block of any matter. Okay, the particles of matter are very small or tiny. These particles are so small that is beyond our imagination. Now I explain one experiment to show that the size of the particle is so small. For example, in this experiment, we take 100 ml of clear water in a beaker and put a very small crystal of potassium permanganate in it. The whole beaker becomes purple. Now, in another beaker, we take 100 ml of clear water and pour 10 ml of solution from the first beaker into it. The second beaker also become purple colored. Now we take a third beaker, 100 ml water in it and pour 10 ml of color solution from the second beaker. This beaker also become color and so on. So you see, in all these beakers, potassium permanganate particles are there uniformly distributed. Although color becomes some fade, but you see the number of particle is all in these beakers. So we can imagine that how many particles are there in a very small crystal of potassium permanganate. Another example here is one small droplet of water contains 1700 million number of particles, that is water molecule H2O. Okay, so now we can conclude that the particle size of matter is very small and every matter is made up of particles. Now, characteristics of particles of matter. Particles of matter have space between them. All matter is constituted by particles. But the arrangement of particles is not very close. That means they maintain some distance. Although the distance between the particles vary from matter to matter, but there must have some space between the particles. Okay, let us see or prove that particles of any matter have space between them by an experiment. We take some water in a beaker and mark the level of the water, say at least 50 ml or 100 ml. Now add 1 or 2 teaspoonful of salt in this water and stir it to dissolve the salt in the water. Now after dissolving the salt becomes invisible. Now we cannot see the salt, and if we observe the water level mark, the level does not rise. At least we cannot see in naked eye or in physical common observation. Now the question is where the salt is gone, or uh, where is the volume of salt. The explanation of this experiment is that the water molecule have space between them, and when we add salt to the water, the salt particles fill the gaps between the particles of water. You can see here the salt particles occupies the gaps between the water molecules. That's why the volume of water level does not rise. Now you can understand and prove that particles of matter have space between them. Okay, see, all matters have not don't have equal space between them. For example, uh, solid particles, uh, solid matters, particles have very little space between them. In liquid matter, the particles have more space between them. When this sugar dissolve in water, the sugar particles occupy the space between the water molecule. This is the solution where the sugar or salt particles occupy the space between the water particles or molecules. Okay, it is clear. Now we go to the next topics. Particles of matter are in a continuous movement. Particles of matter is not fixed in a position. These particles are in a continuous motion. Okay, this motion is random in all directions, all possible directions. One particle is actually starts moving in straight line, but when it collides with another particle or the wall of the container, it changes its direction and it moves randomly, restlessly. The particles are not in a rest for a fraction of a second, always in a movement. This movement is called Brownian movement after scientist Robert Brown, who discovered this movement. Okay. Now, how can you observe? How can you explain that particles move? For example, you see, you observe that when an incense stick burns in any corner of a room, the fragrance or smell of incense stick spreads over all the rooms. Although there is not any air movement or air circulation, but this fragrance is spread very quickly. This is due to the movement of the particles of incense stick vapors through air, and air particles are also moving. In liquid, we can also explain the fact if we drop one color, for example blue color, in a bucket of clear water, after few minutes we see that whole bucket becomes colored blue color. We need not stir the solution. So how the particles spread throughout the bucket? This is due to the movement of the colored particles of the matter and also the water particles movement. Okay, you understand? Is this clear? Okay, thank you. Now we go to the next property. Particles of matter attract each other. Particles of matter attract each other, that is, they have intermolecular force of attraction. All particles in a matter attract each other, although the attraction may vary from matter to matter. Okay. For example, if we hammer an iron ball, it does not break. Okay. But if we hammer a chalk, it will break into pieces. Why iron does not break, chalk breaks? This is because in iron object or in iron matter, the particles of iron are strongly bound to each other. That is, particles of iron have strong intermolecular force of attraction. Whereas in chalk particle, in chalk the particles have intermolecular attraction but not as strong as iron. Therefore, it breaks down. Okay, let us see in gaseous state, for example, carbon dioxide, oxygen, etc. The interparticle attraction is very small, almost negligible. That's why the particles spread all over the container. Okay, and density of gas is very less. In liquid, the attraction is medium and the particles can move through the volume but cannot occupy all the spaces of the container, but they can move through to some extent. But in solid, the interparticle attraction is very high, and that's why they are closely packed and cannot change their position or move. Okay, that why solid have big definite shape. Okay, now let us go. We have completed our discussion of particles and their structure in a matter. Now we see some questions of on these topics. First question is, under what conditions something is called matter? Under what condition something is called matter? Okay. Next, which of the following are matter? Chair, air, love, smell, hate, almonds, thought, cold drinks, smell of perfume. Next, by which process the fragrance of burning incense stick spreads all around? A substance has no mass. Can we consider it as matter? Why a drop of Dettol is evenly distributed in a bucket of water without the need of stirring? A piece of chalk can be broken into small particles on hammering, but it is not possible to break a piece of iron on the same fashion. Why? A diver is able to cut through the water in a swimming pool. Which property of matter does this observation show? What are the characteristics of the particles of matter? A wooden table should be called solid. Give reasons. We can easily move our hands in air, but to do the same through a solid block of wood, we need a karate expert. Give reason. So, students, we will end today's class here. If you face any problem to understand the subject discussed here, or the homework given to you, that is to solve the homework, you can call me or WhatsApp me. So, see you in the next class. Until then, goodbye to all. Thank you.